So now that we're done with this, we'll go ahead and collapse this up, and then we'll go ahead and add in our next part. Now again, we're down here. Oh, I was clicking around over on tools. So if you look over here under, well, essentials and model and all that, we're still in part design, right? So you come up here to draft lab, to the product, double click on that. So we change back over to assembly mode, and then we can add in a new 3D part. Go ahead and click that and select that. It'll add it in, and let's go ahead and name it. Draft top, how about that? Now, another way to kind of go about making things is if you don't care about designing in context, as I was saying, about designing it and being able to see it as you make it, come up here and just hide it. Hide it right off the get-go. So right from the beginning, you're just starting as though you were making a new part. And then because you know that you're maybe getting comfortable with assembly, it doesn't really matter where it goes. Matter of fact, you know what? I'm gonna change this just a little bit, right? So just to show you where this is at, see it's sitting here like this, just to prove something. I'm gonna go ahead and hide this. Then we'll open this one up, double click on part body so we get into the part design workbench. And then I'm gonna pick this side plane right there, completely sideways. And I'm gonna go to Sketcher. Now, I can start making the rest of my shape. So I'll go right here, and this is a different topic, okay? Remember when we first made the shape for the base, and let's do this. Let's hide this. Let's bring this back. So we go back to when we were drafting this out. And there's a couple pretend examples, you know, kind of like, let's see, I want to have it draft from this way going up like this, or oopsie, I made a mistake, I wanted it drafting down or whatever, right? But ultimately, we decided to draft it out. So the bottom is larger than the sketch for the square that we made on the top here, okay? The original sketch here for this pad was 50 millimeters square. There's our 50 millimeters, okay? If we would have decided to draft it from the bottom inward, okay, then this top will have a dimension that I can probably tell you is not going to be a nice even number, because let's say this bottom one was 50. See if this makes some sense. If this was 50 and we angled it in, drafted it in 20 degrees, 23 degrees, whatever it was that we picked, this square up here is going to be some strange measurement. And then if I want to make the top part fit nicely, I'm going to have to measure that and make sure that I make the base of this top part match that exactly. And let me just say right now, it's not the best thing in the world unless you have to have a critical feature or a base feature, you know, like the main sketch of a block being something like 23.53794 millimeters, you see? So by drafting the bottom out instead, by thinking ahead and having good design theory, good design practices, we make this one be 50 and we draft it out. So we know that later when we go to put the top on this, it's a nice, clean, even number like 50, okay? Hopefully that makes sense. I'm also hoping that maybe as time goes by, we'll see this in action and we can kind of call back to what I just said. So I'm going to come back up here. I'm going to hide this and I will show this, and I will double click on the part to get into this part design. And I didn't actually dimension that, so let's get back into the sketch. And we'll make this one 50 by 50. Exit and pad this up 30. Okay, so there's our base shape. Now we're going to draft this in the same way that we did before. So I come down here, whoops, we get the draft tool. and I'm going to pick all these faces. Okay. And then the neutral element is going to be this down here. Does it matter? No, because we're going to assemble it. It'll matter later which side I use to put that little tab onto that I showed you earlier. But right now, I mean, I could make it go either direction. But what I do need to be aware of is this side right here, the smaller side, needs to remain 50. So this one right here, what was the other one? 20 degrees, right? So let me change it to 20. You see this angle right here? It's going outward. So I need to flip, what's it called? Right here. I need to flip the pulling direction. Now it's going inward like that, okay? And preview if you like. See, that's going to happen like so. And here's what I'm talking about. Because I made the sketch right here and I drafted it inward like this, I know that this lower section is 50. But this is a good opportunity to show you another tool that we haven't talked about yet before. So if you come down here to the tools section and you look right here, there's a little arrow and it's got a block on it like so. Hit that. This is the measure between. So I can go right here, I can pick that line right there, and I can pick that line right there, and it tells me that in my cursor right here, don't worry about this window so much right here, it says there is a minimum distance of 50 millimeters between there. Okay, so we're going to need this one later. So for example, if I had an assembly and I was designing this to fit in another portion that I already made, I could go over there, I could measure it, I could see what it is, and then I could make the part fit in the hole or on the spot. All right, so what next? Well, it's the same thing, but in reverse. I'm going to go to this lower face right here, and I'll go into Sketch, and I will make a centered rectangle. Now, what do I do with this? What do I do? So do I make it a certain dimension, or do I make it so far from the edge? Well, if I make it so far from the edge, I think that's going to be best because it's going to fit right down in the hole, should fit roundaboutly the same way as the other. So that's what I'll go with. If you had any concern about that, what you could do is you could go find the original one, like I was just saying, and you could do that measure between, and you could see what the hole is, and then maybe that's a dimension that you'd use for this whole rectangle. For this exercise, I'm going to do this from there to there, just as we did before, 5 millimeters. This one from here to there, 5 millimeters. Exit Sketcher. Oops, I hit a button. And then we're going to pad it out. That sketch right there, 3, just like the other. Okay. Now, that's it. So there's our part again, getting a little bit quicker, hopefully. And I'm going to make this be a different color. Last time I think I made it kind of bluish. Can't really remember. If you like, you can go here to more colors and you can pick out other ones. I think I just went with something like that. I don't know. Good enough. Okay, so there's that part there. But now let's look at it along with the other one. So I will unhide this one, and then we'll go up a level to the product. So we'll hide this, and you notice, ooh, it's all crooked. So double click on that. Okay, so does this matter? Does this matter at all? Well, I hope that you see now, from what we've been doing with assembly and even our first lab where we just, we tipped the block top over and sideways and gave it a twist. It doesn't really matter what its orientation is here because we're going to assemble it to this one. What I will say is if you aren't careful and you don't follow a certain procedure first, as maybe you should, things might get a little out of hand. And what that is this purple one right here, let's say that this is XYZ just as I like it to be. So if I look at my compass right there, I just wanted to stick it up on something straight, like that plane. Z is up. That's all I want to say, really, is Z is up, and X and Y is going the way that it should be. This one here is definitely not as far as a little pyramid shaped thing that's going to sit on the table, right? So if you imagine this is sitting on the table, this is going up here, this is Z. So this one here, this part needs to be the one that's fixed. If you don't do this, when you constrain something, it's possible that this part here might turn and rotate to match maybe this one. So that's what I want you to be mindful of, all right? I'm going to close that up just to make things look a little bit nicer. And then we can get to constraining this. So how are we going to do this? Well, maybe if we want, if it helps you, we can move it around, remember, as long as we're in assembly mode first. So you look down here, yep, that's assembly. So go ahead and stick this on the part, and I'll grab one of these and I'll lift it up, and maybe I'll give it a rotate. You know, again, don't worry about making it exact. The only reason I'm doing this right now is because maybe if you're trying to sort out a solution on how you're going to connect it, it might be maybe more helpful for you to look at this thing in somewhat of its close position, so you can go, oh yeah, wait, I'll connect this to this, okay? So I think for this one here, we'll go back to what we did in the first lab with the square block, the last section of it. I want to make possibly this one here connect to that face right there, and then how about this one right here connects to this edge right down there. Okay, so let's give that a shot, and then I will make, well, probably another video after this about a different concept on this. Okay, so maybe simple enough. I'll go to my constraints. Now think about this too, by the way. When you go to constrain this, it's going to move to that position. And if I were to do my contact constraint first, it's going to move there now. And maybe that makes it a little bit harder for me to get at that edge. It's definitely not impossible. You can slide it away or whatever you want. But that's just a thought I wanted to mention. So if you, again, are thinking ahead, then maybe what I'll do is, I'll just start over. I'll do a coincident constraint between that edge right there and this edge. So they won't go touch, right? They'll just align straight to each other. That one right there. Okay. And remember how it could be twisted. So I need at least two of these. So I guess I'll grab that corner right there. So I'll do another coincident. I'll pick that one. And I'll pick this one here. Okay. Now they're lined up. It didn't really move because this was still straight right over the top of it. Okay. Now, theoretically, I only have the, the one or small amount of degrees of freedom left because it can go up and down, right? So now I'll do my contact, and I'll pick this one right there, and I'll pick this one right here, and it will connect together. Hit OK. Again, don't worry about that. And there's the thing done. If I come over here and I pick the one that I did not anchor, okay, so the draft base, pick the top or any other one that you might have, and then we go to object, we go to component degrees of freedom. It says there's no degrees of freedom. Everything is all good, okay? All right, so that's basically it for the draft lab. However, I want to pose a problem. This section right here under the engineering constraint that we just did here, this one, the coincident constraints on the edges, they are aligned with each other. However, you know what I'm going to do here? I will delete this one just so I can show you. I have this line right there perfectly in line with this one. Then there's another one over on a corner that's perfectly aligned up with the other one. So what's going to happen if this block changes size? Why would it change size? Well, remember in the last lab, I mentioned that this portion right here, a peg like this, will not fit in a hole that is the same size. And this is the same case. This will not, in real life, actually fit in here. So I need to either open this up and make it larger, or I need to make this one a little bit smaller. If I do that, because I just realized it, maybe I went and made the thing, I 3D printed it, I milled the thing out and went, oh man, they don't fit. I forgot to do the tolerance. But I've already done the assembly on this. As soon as I go back and I modify this and I shrink it, I'm going to get an error with my assembly because these portions right here are not in line with each other any longer because it's smaller, okay? So, what's a better way to do this that maybe won't change as time goes by? That's what's going to be the next video.